So, could I have the next slide, please? This is my official welcome to a Proba in collaboration with Agrifirm webinar about gaining control of your Scope 3 by building resilient low-carbon crops supply chains. I think this is a really exciting webinar from our side because we've been working with Agrifirm for a while, and I'm really happy that we can finally sit down together and talk about this, talk about some of the interventions we're looking at and the results that we're seeing from this. It's at least from my side, it's a very exciting thing. We have we're going to have an hour session divided between two speakers, and we're going to have a Q&A towards the end. So if I can also have the next slide, please. We will leave the questions for the end. If you have them come up during the webinar, please click on the meeting tools icon on the bottom right side of your Google Meet screen and click on the Q&A section to leave your questions. During the webinar, I might try to answer some of the questions, but we will dedicate 10 to 15 minutes towards the end to delegate the questions to one of our two speakers. Anything that comes up is welcome. And now, without further ado, here are also our two speakers. Next slide. We have Levi, not Levy, Levi from Agrifirm, who is a concept manager and an agronomist. And we have our co-founder, Rutger Baines. I hope that's also good. A good enough pronunciation. Who is our co-founder and go-to, like our everything guy at Proba. And I think I said everything that I needed to say, and I want to pass the baton to Levi.
Thank you, Erna. So indeed, welcome everyone. Just to briefly kick off, why are we doing this webinar together? Because at Agrifirm, we are working together with Proba to secure a low carbon cultivation of specific crops. And that's what we want to talk to you about today. So first of all, we'll start very briefly about Scope 3, since this webinar is concerning Scope 3 emissions. And what are Scope 3 emissions? They're the indirect greenhouse gas emissions that occur across a company's entire value chain. And so not only the greenhouse gas emissions that occur when you during your own operations, but also the emissions that occur within your own procurement and your own sales activities. And that's why it's quite an important amount of greenhouse gas emissions that play quite a large role. And as you can see here, a breakdown of percentage-wise of Scope 1 and 2, which is your own operations, as well as Scope 3, which is, as I mentioned, your indirect emissions. And as you can see, for quite a number of important sectors, this is quite a large chunk of your greenhouse gas emissions. Today, we're focusing on food. And as you can see over there, it's at least 85% of your emissions is coming from Scope 3. So quite a big emission route that needs to be tackled if we want to decarbonize our operations. So as said, we're focusing on food today, and more specifically on the Netherlands, and then even more specific on arable farming in this case. And just a few statistics, especially for those who are not from the Netherlands. What are we talking about here? We're talking about the main crops, the main arable crops in the Netherlands being wheat, barley, potato, sugar beets, and onions. As you can see here, we have quite a large cultivated area of these crops, and I can say our yield is quite high. So we can safely say that the Netherlands is quite a big producer when it comes to these crops, and thereby also they have quite some impact on your total emissions when it comes to your Scope 3. Now these crops, important to say, these crops in the Netherlands are always grown in a cultivation plan. So one segment of land, one parcel of land is never having all of the crops year on year, but they always rotate. So that's important to note. So we're talking about a crop rotation here, with wheat, sugar beets, onions, and potatoes being the main crop rotation we can say. Now, what is Agrifirm? We are a farmers cooperative, so we are owned by farmers, and we try to help them in their daily operations. Myself, I work for our division called Plant-Based Solutions, where we have around 120 advisors working on the farm level. They give crop advice, We also buy and sell wheat and barley. We sell inputs needed for cultivating crops, like fertilizers, crop protection, and we try to always focus our innovations to deliver or to solve bottlenecks of these growers. Our impact is quite big. Our scope is the Netherlands. We have around approximately 30% market share. In total as Agrifirm, we have around we are owned by 8,000 farmers, but that's also including dairy and other meat and meat production, focusing on plant-based solutions. We are mainly active in arable crops, fruit trees, full field vegetables, fodder crops, and flower bulbs. And as I mentioned, we try to solve the real bottlenecks that our growers are experiencing, whether they be based on crop protection, so protecting your crops against diseases, where we, for example, in potato, are trying to control blight better using our total blight approach, or using our tools to improve nitrogen use efficiency, to reduce the nitrate leaching, and to improve the nutrient use efficiency of crops. And how we are working together with Proba on the third pillar, which is sustainability, where we're trying to turn KPIs around, for example, biodiversity or soil health into action, so that the farmer can really set steps in improving these KPIs for him or herself. And there we try to follow a regenerative approach, focusing on the 4 pillars within the SIE framework, being climate, biodiversity, water quality, and soil health. And today we're focusing on the first one, which is climate. And as I mentioned there, we are partnering with Proba to see how we can actually certify our carbon footprint reduction initiatives. And we always try to stay aligned with SBTi and SIE, and of course other net frameworks like in the Netherlands, the BMA. That's quite specific for the Netherlands. And now what does this look like in the field? This is a nice picture of one of my colleagues. You can see on the left. This is Erik. He's working in the south, and he's helping a farmer with a cover crop, checking the rooting, and also, in this case, practically in the field advising how to grow a healthy crop. But it's more than that. It's also making a good crop rotation plan. It's helping with fertilizer plans, crop protection plans, really helping the farmer take steps in improving his yield or improving his sustainability, and being a partner for the grower to help him reach his goals. That's what we do on a daily basis, and how we assist the growers. Now, if we zoom a little bit on greenhouse gas emissions from arable agriculture, the climate aspects we're focusing on today, we can see 3 main routes where we have the greenhouse gas emissions coming from, either being in-field emissions, then we're talking about nitrous oxide, mainly in this case, the carbon footprint of fertilizers, and the fuel. Those are mainly in arable agriculture, the big emission routes that we're trying to tackle. And today we'll focus a bit on the product carbon footprint of fertilizers and on in-field emissions. So fuel will be mentioned, but it will largely be focused on the left 2 emission routes. And then if we zoom in a little bit on a little bit more on those two routes, we have the production footprint of fertilizers. It's mainly nitrogen fertilizers that we're talking about today, because they have they're the main products when it comes to carbon emissions. And as I said, these 2 products have 2 main emission routes. The first one being the production. So when nitrogen fertilizers are produced, they come with a product carbon footprint, mainly because they're produced using natural gas. And the use of this natural gas results in a footprint which has to be accounted for within the nitrogen fertilizer, meaning that the product is sold with a certain footprint, which has to be accounted for somewhere. So that's the first one. That's the PCF, so-called, the product carbon footprint. And the second one is in-field emissions, and there we're mainly talking about nitrous oxide. So when a mineral nitrogen, so one coming from the fertilizer factory, or an organic nitrogen, so one coming from manure or compost, is applied to the field. Natural processes in the soil called nitrification occur, changing the nitrogen from one type to the next, from ammonium to nitrate to be more specific. And there we have an emission route called nitrous oxide emission, and that accounts for quite a large amount of greenhouse gas emissions, because it's a very strong greenhouse gas. So 1 kilogram of nitrous oxide accounts for 300 kilograms of CO2 emission. So it counts quite heavily, and therefore also reducing this one is quite a strong focus for us. Now, if we zoom in a little bit on what does this mean for the total carbon footprint of two specific crops. This is coming from a source of our branch organization, BO Akkerbouw, and they have mapped for the sector where the main carbon footprint is coming from in cereals and potatoes. And as you can see on the left hand side in the pie chart for cereals, you can see that 68% can be attributed to the PCF, the product carbon footprint of nitrogen fertilizers, and the infield emissions. So already a very big chunk is coming from those two emission routes. For potatoes, in this case especially potatoes which are stored after harvest, the breakdown is somewhat different. You can see around 48% is there related to infield emissions and the production of nitrogen fertilizers, while the other routes are quite a lot smaller, especially except for diesel, which is also quite a heavy emitter. Now, when we briefly touch upon how we can reduce these greenhouse gas emissions in the field, and what we call the mitigation strategies. First of all, we have to focus on improving our nutrient use efficiency. This is it might for a lot of people on this call, this might be a no-brainer, but the 4 R's of nutrient stewardship are very important here. So, meaning that the timing and the rate and the place of application is extremely important when it comes to improving nutrient use efficiency. And well, Rutger will touch upon that later a little bit more, but we feel that there is that we, with the right interventions and the right strategies to improve our nutrient use efficiency, we can really set some good steps in reducing greenhouse gas emissions, simply because when you apply less and you can still maintain your crop yield, there's less losses, so less nitrous oxide emissions, and of course less nitrogen which has to be produced, and meaning a total lower amount of product carbon footprint that is being applied. So first of all, improving nutrient use efficiency is a big one to start with. There's always methods and ways to improve this and to be able to decrease losses in the field. Secondly is reducing, of course, the product carbon footprint of the fertilizer, the nitrogen fertilizers. And of course, there might be some people here in this call who know much more about this than I do. But if we summarize it a bit, we believe there's 3 routes to reducing this product carbon footprint. And again, others will be much more knowledgeable on this subject. But the three routes will mainly be reducing nitrous oxide emissions during production, and that's route number 1, meaning that when nitrogen fertilizers are produced, certain technologies are applied to make sure that no nitrous oxide, which is a byproduct of nitrogen production, is being lost to the atmosphere. And this is already a big step in reducing the total product carbon footprint. And we see that European producers have done this already quite well, and so they are already quite advanced in reducing this type of emission. But with products coming from outside of the EU, this is not always the case. Secondly is capture and long-term storage of CO2. And so again, when producing a nitrogen fertilizer using natural gas, the carbon coming out of the CO2 coming out of the production plant can be captured and stored. This is also a very big game changer when it comes to the total product carbon footprint of a nitrogen fertilizer. And lastly, also a very important one, replacing fossil natural gas with green inputs, being either biomethane or being green hydrogen for the production of green ammonia. So we believe that these three routes are the main ones to reduce our product carbon footprint when it comes to nitrogen fertilizers. And thirdly, we can also touch upon reducing our infield emissions, where we have three main routes to do this. Besides, of course, the route of improving our nutrient use efficiency. On the left-hand side, you have the urease inhibitors. There are less of since in the Netherlands we don't use too much urea. This is less of a big intervention in the Netherlands, but basically, a urease inhibitor can also reduce the emission of nitrous oxide. But the main one we believe in the Netherlands is either the nitrification inhibitors, which you can see in the middle here, where a nitrification inhibitor reduces the rate of change from ammonium to nitrate by reducing the soil process, meaning that the process does take place, but it's being slowed down a bit, and thereby, of course, less of the ammonium is being transferred to nitrate. Also, this improves the nutrient use efficiency, but mainly it reduces our greenhouse gas emissions. And the third one, also quite a nice technology for the Netherlands, which we are already implementing, is controlled release fertilizers, where the mineral fertilizer is coated with a coating, which means that the nitrogen does not come into the soil or does not become plant available nitrogen right away, but it's released over a period of time, depending on temperature and depending on moisture, meaning that the plant does not receive a huge amount of nitrate or nitrogen in a short amount of time, but it's being more slowly transferred through time, improving the nutrient use efficiency, and thereby also reducing losses like leaching and like nitrous oxide emission. So those are the main strategies to reduce infield emissions. And if we look at the middle one, nitrification inhibitors, it can either be used in organic manure or organic nitrogen, or it can be used in mineral nitrogen, regardless of the type. I mentioned that Rutger would share this, but I think I'll be the one that is sharing this, because we have here the percentages of greenhouse gas emission reduction that can be gained. And we start on the right-hand side, reducing infield emissions. First of all, we can really improve a lot. We can strongly improve on our nitrogen use efficiency, or our nutrient use efficiency, and there we can already set some big steps. Almost reducing infield emissions by 5 to 50%. Controlled release fertilizers also are a big chunk. It could potentially amount 30 to 60% of infield emissions. And the nitrification or the urease inhibitors, the stabilizers, which you can see on the left, they amount to 30 to 70%. And then if we go completely to the left, there we have the production emissions of nitrogen fertilizers. And there we can we estimate that with a decarbonization of the whole production process of nitrogen fertilizers, regardless of availability of green hydrogen, and regardless of availability of biomethane, but potentially the reduction can be as much as 98% in terms of the product carbon footprint. And so the potential to reduce our total greenhouse gas emission in the field or of our crops is quite big. Now, what does this look like in the field? And what can a farmer do based on the three mitigation strategies that we discussed to reduce his carbon footprint in the field? And here again, we're focusing on the nitrogen fertilizers. So there's there are several different routes. We mentioned, of course, the low carbon nitrogen, so the nitrogen with a lower product carbon footprint is, of course, an important one. The controlled release fertilizers we already discussed. And besides this, we have the nitrification inhibitors being either implemented on organic nitrogen, so manure or compost, and the nitrification inhibitors being applied in mineral fertilizers. And on the other hand, we can also have different strategies to improve our nutrient use efficiency, either focusing on biostimulants, where it's quite well. There's still some potential there to gain a better nutrient use efficiency, but this is quite a difficult one to prove, to actually have scientific backing that the emission reduction that we claim actually takes place. We have the nitrogen foliar fertilizer, which can be applied, so you can reduce your total amount of nitrogen by applying it as a foliar fertilizer. Of course, this does not cover the complete nitrogen demand of the crop, but at least you can reduce your total nitrogen input to an extent. And lastly, decision support systems. So, for example, measuring, as I mentioned earlier, through balansbemesting in potatoes, trying to understand the nutrient status of a crop during growth, and applying nitrogen based on the crop requirement at that moment. And that's also a big one to improve the nutrient use efficiency. So the left side, mainly on the inputs, and on the right hand side, mainly on the efficiency. So those are the strategies which can be implemented and which we are already implementing with our growers. And Proba is helping us to calculate and to map the exact amount of CO2 reduction that we can obtain using these interventions. Now, of course, we can implement these strategies on a farm level, but the farmer also needs to, of course, to adopt these different strategies, and especially when considering projects with, for example, food chain partners, where we, together with food chain partners, try to reduce the scope 3 emissions of certain crops. We need the farmer on board there to actually, implement these strategies. To implement, for example, the nitrification inhibitors or the low carbon fertilizers. And we already have some successful projects running on this, on this topic. So we have already been doing quite a bit of learning there. And I think that over these past years, we are starting to understand a bit more, what is a farmer's interest to actually join these programs. And with some of the learnings we have made over the past years, and this is of course not a complete list, but it's first of all no abrupt changes to their current practices. So the strategies we implement should try to be able to fit the strategy of the farmer as good as possible, because this makes implementation as easy as possible for them. Secondly, interventions should be risk-free for a farmer, so there should be no risk of yield loss, for example, when implementing a certain carbon footprint reduction scheme or strategy. That's quite important, also for your total greenhouse gas footprint, of course, but especially for the farmer to be able to implement these strategies. And what really adds on to this is that a farmer would like to have a proven intervention. So scientific research is quite important here. Testing out products, trying products, seeing how they fit into the Dutch circumstances, and making sure that what we implement in the field is actually is proven and does not lead to yield loss, but rather yields an improvement of their yield. Farmers also don't want too much hassle around audits, which is quite logical, of course. Another one, having to audit their complete system. So there we also try to play a role. And we need, of course, a certain financial motivation to implement changes. Of course, this depends on the amount of changes that need to be made to the current practices of the grower. So if we have an intervention that actually also improves yield, or that reduces losses, then a farmer is of course much more willing to participate than when a certain program adds costs. And only in that case, a certain financial incentive needs to be there to make sure that the bill does not end up on the farm level, because that does not work. And now, as I mentioned, we've already been doing some projects with food companies like yourselves. And in our view, and of course, again, you know this better than I, but in our view, what do food companies want? Supply security is an important one. So making sure that they maintain their supply of raw materials, and that there's no yield loss, and that there's no risk of losing input for their vital processes. Also, scalability and cost efficiency is a big one here, which is of course logical. Assurance, so making sure that what we do and what we claim is actually also risk-free in terms of greenwashing, that there's no greenwashing involved, and that there's that the interventions we do are actually proven in terms of greenhouse gas emission reduction. As I mentioned, no negative effect on crop yield and quality, quite an important one. Co-benefits, strongly working on co-benefits at the moment. So, for example, combining regenerative practices with greenhouse gas emission reduction, and of course, SBTi compliance. Those are important factors to take into consideration, and we take these in consideration when designing a project. Well, a lot of these points were already touched, but then how do we as Agrifirm bridge the gap between the farmer and the food company? First of all, we make sure that our interventions that are being used are proven. And so on a yearly basis, we do a lot of trials, especially at universities, to see how certain interventions play out in the field. Think about coated fertilizers, think about nitrification inhibitors, biostimulants, and below you can see the picture of one of our trials where the outlined boxes show a greening effect, meaning a positive result of a certain fertilizer interventions. Of course, when we have an intervention that is proven and that's effective for the Dutch circumstances, and we have a project where a certain crop needs to be grown with a lower footprint, we go to our farmer address book and we onboard farmers. Farmers that are enthusiastic to participate, that like to do these projects. We help them with a plan, a cultivation and a fertilizer plan, to make sure that the interventions are also implemented correctly. And of course, we follow up during the season with evaluations, and also we advise them during the season. And also here, very important, our data exchange with Proba comes in for the whole verification, for all validation of the interventions. And lastly, but not least, external validation and verification comes into play. So that's the role that we see as Agrifirm and Proba in this exchange, with Proba focusing more on the certification and the validation, and Agrifirm focusing more on the farmer the farmer side and the agronomy side. And that's a good cooperation in our view. So then I'll give the floor to Rutger to talk a little bit about some preliminary project results that we have had this year.
Yeah, thank you, Levi. You can go to the next slide. Yeah, so overall, I think Levi already nicely captured it. Of course, assurance is important here in SBTi compliance, but I believe we're also asked because we are specialized in fertilizer-related emissions. So we are also helping, I would say, in quantifying and modeling different scenarios to understand which interventions are feasible from a technical but also commercial point of view. And then, of course, we quantify the actual emissions, and we organize certification. Next slide. Thank you. So if you look at the total stakeholder overview, and then Agrifirm has a large role in the middle where they have multiple responsibilities. On one hand, they are fertilizer distributors, so they are, I would say, in a right position to make sure that farmers have access to better fertilizers, but also provide the agronomy support, to advise them on what works best, and collect data from the farmer in order to support the validation and verification. Farmers, of course, I would say the most important player here to actually implement those interventions and report back to Agrifirm. And on the left-hand side, you see the different input providers. So these can be, for instance, the producers of fertilizers, and on the top, the agri-buyers who provide, I would say, the incentives, financial incentives to Agrifirm and farmers in return of what we call impact units, which allow them to report lower scope 3 emissions. And as Levi mentioned, on the bottom, we have the external auditors who provide validation and verification services. So hopefully that gives a good context of where we are. Aim of this project was really to focus on reducing the footprint, lowering the footprint of 3 crops, potatoes, barley, and wheat, by reducing fertilizer-related emissions. Levi mentioned also fuel-related emissions that we also include in this project, but I leave them out of scope because of, I would say, the limited complexity of quantifying those emissions. Next slide, please. So what we typically start with in a project like this is identifying the different interventions. I think most of them were mentioned by Levi before. Important is that we understand what is I would say, the impact of those interventions. Can be impact on, for instance, your fertilizer rate, your nitrogen rates. Can also be impact on production emissions, infield emissions, combinations of both. And very important is that we also analyze whether we're able to quantify those interventions. Not all interventions can be quantified. For instance, because there's no methodology available, not from Proba or from other providers, or because there's simply not enough scientific evidence to support those reductions yet. And next slide, please. In order to give you a bit of understanding on the results of the project, it's probably most easy if I walk you through a couple of scenarios. So I picked 3 typical, I would say, representative farming scenarios that we saw this year for 3 different crops. At this moment, we don't have all results in yet. But this gives you, I think, a pretty good understanding of what the impact can be of these interventions. So if I take winter wheat as first example, typical baseline, and baseline is what we call, I would say, the business as usual scenario, is that a farmer uses, in this case, 131 kilograms of nitrogen per hectare using conventional Chem 27, an additional 114 kilograms of Chem 24S, added sulfur. Total emissions there, they accumulate to approximately 185 kilograms of CO2 per ton of wheat. The interventions that were applied here, so the change that was performed for this growing season 2025, was that the Chem 27 was replaced by a combination of low carbon variant of the same, so the very same product, but then with lower production emissions, in combination with foliar nitrogen. So I think Levi explained it a bit already. It basically means applying nitrogen not on the soil, but directly on the leaf of the crop. Which results in a total nitrogen rate reduction of 12%, and in combination with, I would say, the lower production emissions of the low carbon variant, that results in 65% lower production emissions and 27% lower infield emissions. Similar was done for the Chem 24S, but there it was replaced by, I would say, a low carbon variant, but also there were nitrification inhibitors introduced. So there you see a similar reduction of production emissions, but additionally a very large infield reduction by almost 70% by introducing those nitrogen inhibitors. So if you then go to the next slide, then you see that results in approximately 50%, 49% of the reduction of the fertilizer-related emissions for 1 ton of wheat, winter wheat. So that I would say that drops to approximately 94 kilogram of CO2 per ton of wheat, which is, I think, is a very significant reduction here. Maybe the next example I want to show you is for barley, and here I took a scenario where there were already very low emissions, because this farmer is only using organic fertilizer, so no mineral fertilizer is used at all. So it's only 130 kilograms of nitrogen based on cattle slurry, and it results in already, I would say, relatively low fertilizer emissions of 77 kilograms per ton of barley. But what we did here, or what the farmer actually did, is replacing the slurry with a slurry including nitrification inhibitors. which allows to reduce the amount of slurry applied with 8%. It's a relatively small reduction, but still having a significant impact. And more importantly, reducing the infield emissions with 41%. And of course, the infield emissions here are the majority of the emissions because there are no production emissions accounted for when using slurry on the barley. So therefore, of course, the production emissions they go up here by introducing the nitrification inhibitors, but that's only very small. If you can then go to the next slide, and the results in an overall reduction of 40% for the fertilizer-related emissions for barley. And maybe the last example I want to show you, that's for potato. And I think Levi already explained for potato, I would say the share of fertilizer emissions is significantly smaller than for the other two crops, but still very significant. And here, a typical scenario we see is that a farmer uses a combination of regular CAN 27 and cattle slurry. So in this case, one on 74 kilograms and one on 67. Maybe for the potato expert, it's a relatively high number if you look at the, let's say, the nitrogen limits in the Netherlands, but that's because of the working coefficient of the slurry. And therefore you can use a bit more nitrogen, I would say, than allowed. The intervention that's happening here is that I think Levi already explained a bit more the control release fertilizers. So here we're experimenting with the effect of introducing CRF and replacing the CAN 27, and that allows for a rate reduction of 9%. So overall nitrogen rate reduction of 9%, which then results in 21% lower production emissions and almost or a bit more than 28% of lower infield emissions. And then if you go to the next slide, because the cattle slurry is, I would say, unchanged here, that results in overall reduction of 14% of the fertilizer-related emissions for potatoes, basically by introducing as one intervention, which is switching to control release fertilizers. A very obvious, I would say, improvement here would be also introducing the nitrification inhibitors for the slurry. I think you can easily double then the reduction here and probably get to approximately 30% of reduction for fertilizer-related emissions. Next slide, please. So currently, as mentioned, I would say the data for the 2025 season is flowing in. We actually visited one of the potato farmers today, Levi and me. And what we see so far is that we did a small pilot in 2025, and we have approximately 1,000 tons of CO2 currently reduced. And based on, I would say, the different scenarios we've seen so far for the different crops and for different scenarios, we see between 10 and 65% of reductions happening there. And this is, of course, really focused on the I would say, the emission numbers and the greenhouse gas numbers. So also curious, of course, but maybe Levi can mention a bit to understand also the feedback from the farmers, because it's also very important to understand that I would say the impact on their practices, but also on their yield was positive. So far what I heard was good, but maybe Levi has more insights on that.
Yeah, no, sure. It's feedback is good of the growers. They like to be part of this type of project. It's quite exciting to be part of this. It's also, for example, with the winter wheat, we really focused on producing winter wheat for bakeries instead of the wheat automatically or being sold as animal feed. So that was also quite exciting for the farmers to focus more on. And you see that especially when you also start implementing interventions which improve, for example, the yield or increase the nutrient use efficiency, that also helps farmers not only reduce their carbon footprint, but also helps farmers navigate around more stringent legislation around nutrient use, and already being ready for a future where we have to be more sparingly with where we have to use our nitrogen more sparingly than what we have been doing in the past. So we see that the farmers are quite excited to take part in this, and the feedback is quite good. I think the interventions that actually improve yields or improve nutrient use efficiency are the ones that are most exciting for farmers. Of course, the green and nitrogen inputs are also interesting, but there it's really not a very big change with regards to their inputs. So it's a bit more dry material, so to speak. So feedback is good. And I think with that, we'll give the floor to Erna. But let me see if we can answer some questions.
Yeah. So thank you so much to both of our speakers. I have the Q&A section open already, so I see a couple of questions flooding in. I just want to remind again the viewers that you can access the Q&A by opening up the meeting tools on the bottom right corner from your Google Meet and entering Q&A. We do have the option of putting these questions in anonymously if you don't want your name being shown, but also we may not be able to get through all the questions. So if you do leave your names, we can maybe follow up with you. So quick thing for Levi, would you be able to enter full presentation mode perchance?
Yep, sure.
Just we can see your entire desktop. So I'm going to read out the questions out loud, and I think whoever feels like they're best suited for this question can start first. One of our first questions that we got during the webinar was, does Agrifirm make its own custom fertilizer blends tailored to the specific needs of their farmers and crops?
Yes, we do, especially when it comes to, we make specific blends, and that also helps us to include products like, for example, controlled release fertilizers or nitrification inhibitors, and to make sure that we also suit our products with the specific crop requirements. So not only to reduce emissions, but also to improve nutrient use efficiency.
Nice. I also have a pretty nice question a little bit later down from Kiana. I apologize for butchering your name if I did. Which model did you use to calculate on-field emissions for cattle slurry? So this can be kind of for the both of you.
Yeah, so Proba developed 3 different methodologies specifically to fertilizer-related emissions, and our protocols they prescribe in detail how you quantify different types of emissions. We use for that what we call our fertilizer emission database, where we collect scientific research on different kind of, I would say, emissions, both for baselines and interventions, which also includes emissions for organic fertilizers. So based on the nitrogen contents, type of slurry, type of soil, that's, I think, those are the most important ones. We establish the emission factor per kilogram of nitrogen.
Nice. Now, somebody was also asking, are there any insights on the costs of the program, for instance, per ton of CO2 equivalent?
Yeah, I think looking at Levi, but I think it's not disclosed completely what the costs are. What I can say about it is that, of course, it varies a lot per intervention. So I think it's probably not a secret that green ammonia-based fertilizers, which are also used in the project, are still relatively expensive. But it's very important to stimulate also, I would say, the development and adoption of those technologies. And inhibitors are, for instance, a relatively affordable intervention. So it depends really on the type of intervention, and it was a portfolio approach here where we really mix multiple interventions and to ensure that we, one, achieve the target of reducing X% of fertilizer related emissions, and two, also staying within a certain bandwidth to keep it affordable.
Thank you. I have one question for Levi from Tom, which is, can the N2O reductions from controlled release and the nitrification inhibitors be considered additive? Do you have any evidence to support this?
Can you repeat the question?
Of course. Can the nitrous oxide reductions from controlled release and nitrification inhibitors be considered additive? Is there evidence to support this?
I think additional.
Yeah,
I can try. So 2 things are important here. So one, it's insetting, and so the rules there are a bit different than with offsetting. But second, important here is that we only, I would say, account for the nitrogen rate reduction on top of, I would say, what are the legal limits. So it's significantly lower than what's, I would say, already being pushed by legislation. And second, there is, I would say, no requirement whatsoever to, for instance, introduce nitrification inhibitors. So switching from conventional fertilizer to a similar rate with inhibitors included, that's already considered additional and reduces the emissions per kilogram of nitrogen. It's a bit difficult question, but hopefully I answered it in a relatively short way. But I'm happy to dive into it in a bit more detail with Tom.
We also have one pretty interesting question, which asks, how were the nitrous oxide emissions measured on the field, so in the field, and how often do these measurements take place?
Cool. So one thing that our methodology does not require is for every project to individually measure those emissions. What is important, though, is that there are scientific studies that have those measurements performed by independent scientific bodies like universities in comparable conditions. So we use different studies in this case. You can, for instance, go to fertilizer-database.com and check out, for instance, our fertilizer database on that, where there are, I think, 500-600 different studies available. And important is that we try to find the most representative studies for those interventions. And in all honesty, it's much easier, for instance, in Northwest Europe to do this than, for instance, in maybe Asia, where there's less scientific research available. So in this case, it was relatively straightforward to get proper scientific evidence to support quantification.
Thank you. I also have sorry to jump some other people's questions, but I have a nice follow-up from Chiara, who previously asked which models we use to calculate the on-field emissions. She was asking, or they're asking, are you working on validating these Proba methodologies with CFT or other global calculators? Do you offer access to these as a service? What geography are they best for?
Very nice questions. So one is yes, we are engaging with the CoolFarm tool in order to integrate, also requested by several of our customers that they want to integrate that. Do you offer access to these as a service? Let's discuss, I would say, offline. Answer is yes, but of course it depends a bit on, I would say, what context you're asking that and what geography they're best for. I think it's fair to say that currently we have quite some research in North America, South America, Europe, China. I think there is lacking some research in Africa and Asia, also Southeast Asia, I think. So there we're also stimulating, we're also engaging with different parties to do more research. So also we see multiple fertilizer producers to also reach out and understand, like, hey, where do you need more research in order to quantify these benefits? Having that said, it doesn't mean that we cannot quantify those emissions at all in those regions, but there will be lower certainty, and therefore there will be more conservativeness applied. Hence, you can probably claim less emissions than you probably actually are reducing in those regions.
Yeah, thanks. I also have another question that's very similar and mentions CoolFarm tool again. It asks us how our methodologies compare to CoolFarm tool and or other methods.
I think in many sense they are comparable, but one is that I think the meta studies that are used, they are a bit outdated. That's one, and also the scope is much smaller. So it acknowledges only a few technologies out there. For example, control release fertilizers are not yet properly supported. Similar for many, I would say, inhibitor types. We are more specific in there, and also have a broader spectrum of supporting that, and which also makes it therefore interesting, both from CoolFarm tool perspective, but also from our customers' perspective, to integrate those.
Thank you. I also have a question for Levi. Of course, this is not written out, but I think it's quite interesting to know. But how do you incentivize your farmers to be on board with a project like this or a program?
Yeah, and also touching a bit on the reply of what we mentioned earlier about the costs per CO2 footprint reduction. It depends a bit on your interventions. I mean, if a certain intervention, for example, an intervention improving nutrient use efficiency in potato only adds benefits for the farmer, it's of course we don't need to incentivize as much as when a farmer needs to buy a more expensive a green nitrogen, for example. And so it depends a lot on the specific interventions. Some are incentivized by that we pay a premium, for example, for the wheat that we buy. And others, they don't really need to be incentivized as much because they already have quite they add value to the farmer in terms of this cultivation. But it's always a combination of those two. As Rutger mentioned, it's really a portfolio approach, meaning that we never only give one specific intervention, but always a combination of interventions to have the best approach possible for the specific project that we are focusing on.
Thank you. And just to be aware of time, I would like to do 2 last questions. I have 2 pretty nice ones picked out. We have one from Rainer, which is it possible to put a reduction number on other application methods like shifting to more smaller gifts? Oh, sorry, to more smaller gifts of nutrients instead of 1 or 2 bigger ones for infield emissions?
Yeah, I can try to answer one. So that what we call precision fertilization. I think that's probably what Rainier is referring to. We're actually starting a pilot together with Agrifirm for the 2026 season. We just started analyzing the scientific evidence, which was developed in collaboration with Wageningen University. And so hopefully within, I would say, 2 to 3 months, I can give Rainier a proper answer. But we are working on that. So the answer is we do not know yet, but we are working on it.
All right, thank you. And now to sort of close things off, there's a pretty interesting question I read from Klaus to both of our speakers. I hope you have your Q&A open, just because I don't want to butcher the readout of these numbers, and I'd like to know your answer.
Scrolling. Is that one about the fertilizer rate?
This is about reducing nitrogen even without inhibitors.
So I think that is probably also related to precision fertilization. So to give a bit of background, what we're doing with that intervention is that twice during the growing season, there is an analysis done of the soil, and there is analysis done twice of the crop. And thereby understanding, I would say, the uptake of nutrients by the crop, but also the availability of nutrients in the soil. And based on that, constantly optimizing, I would say, the application rates of several nutrients. And yes, I believe that early results are quite promising. But also we have to say it's not the most simple. It requires a lot of expertise, which, for instance, Agrifirm has, and which is available in the Netherlands, but maybe is not available in, let's say, other countries. Let's not name specific ones, and therefore it's not maybe the most straightforward and easy intervention. So I agree, but I think we also always need to look at multiple interventions to achieve, I would say, lower emissions.
Thank you. And Levi, do you have any opinions on this?
Well, to be honest, I can't read the question, so I'll move over to Rutger to see it correctly.
Sorry, which one now?
That one. Yeah.
Yeah.
Indeed. So indeed there is room for reducing nitrogen there as well in wheat. So it depends a bit on the specific crop, but there is room there, and indeed also to improve our efficiency.
Great. Thank you. I think these are really some of the nicest questions that we received in some of our latest webinars. So thank you for your answers. Thank you for speaking for us. And thanks to everyone who joined us today here for this webinar. Just as a closing off, these are our wonderful speakers. Here we've put down their emails. If any of this resonated with you, sounds interesting, you want to be a part of it, you want to start something, let us know. And the deck and recording will be shared with everyone in the following days, and we're good. We're done. Thanks.
Thank you.
Thank you.
And we're
Thanks.
good.
Questions.